Hello, my name is Richard Anthony Marca, and this is my CSC 323 week 5 preparation. This time we have 6 things to watch and read, so I will go over them in order. So this is the first video, which is a very short explanation of Firestore, and it talks about what Firestore is, which is a NoSQL document database that's inside of Google Cloud. I've actually used this before in my junior design class, so I'm kind of familiar with this. It talks about how Firestore is suited for mobile applications and web applications without needing to have server management, and it scales automatically. Also, Firestore pushes updates instantly to connect clients, and it has offline support. In fact, I'm going to go over that through the next files. So this is a diagram of how Google Cloud databases exist. So this talks about which database should I use, differences between relational and non-relational. So Cloud SQL and Alloy DB are relational, and non-relational are like Firestore and Bigtable. Spanner is kind of a mixed hybrid of relational and non-relational, but it talks about how the NoSQLs tend to be better for web and mobile apps, news feeds, game saves. Also could be used for real-time analytics, while relational is better for e-commerce and web services, financial services, operational analytics. The best part about the NoSQL, it is a lot more cost sensitive. This video is about what is a NoSQL database, how Cloud Firestore is structured, and getting to know Cloud Firestore. This talks about what Firestore is more specifically as a NoSQL document database. Unlike other types of databases of SQL, which is a vertical scaling, Firestore is actually a horizontal scaling document database. So it's designed for more massive scale data, and it uses a document collection model instead of tables. Because it is horizontal, it can be spread across many servers, and it's better for fast reads and flexible iteration. There are no joins, so you could fetch data from each location separately, and it is schema-less, which fields can differ between documents. It discusses the advantages and disadvantages of NoSQL, where the advantages are that it's an easy iteration, it has flexible data models, faster reads, and automatic horizontal scaling. However, there are some trade-offs. For example, duplicate data means writes are more expensive, and you must manually update duplicated fields, like a profile picture. And you must code defensively because the schema is not enforced. It discusses the Firestore's data model, which has a hierarchical tree of documents, which are fields and values of strings, numbers, arrays, maps, etc. You have then collections, which contain only documents and cannot contain any raw values or other collections. You have sub-collections, and then you have root rules, which are the root of Firestorm, which contains only collections. They also give a nice example of a restaurant review app, where unlike the relational approach of tables of restaurants, reviews, and users, and then you have to use joins, combine data across tables. Now, the Firestore approach has restaurants as a collection, then a restaurant document, and in that document is a sub-collection of reviews, and then you have in that sub-collection a review document, which contains duplicated user info, like names, profile pictures. So why do they duplicate user info? Because Firestore cannot join user data automatically. Fetching user info per a review is too many reads. So duplicating makes reading faster and predictable. It also has query behavior, which is ideal for mobile apps when you load details only when needed. And because it has a horizontal scaling structure, data is automatically distributed across multiple servers. Cloud providers can add and remove servers with minimal downtime, and it enables near infinite scaling. Then we go on to this, which is the data model, where it goes over much of the same things, like Firestore is a NoSQL document-oriented database. The next video is what is Cloud SQL, which is a short video about what Cloud SQL is, which, unlike the Firestore, which is a NoSQL, this is relational, but it is a fully managed relational database server for SQL services inside of Google. It handles provisioning maintenance, replication, backups, and it patches automatically. The benefits for the Cloud SQL are a reduced maintenance cost because Google handles the operations, automatic provisioning for instances and storage, automatic replication and backups, and an easy setup with region, zone selection, and configuration options. You can actually configure the instances based off of the machine type and the storage option, where the two main ones are the SSD, which is low latency and high QPS, and HDD, which is cheaper because it's lower performance. The main thing about the storage options to note is higher storage capacity equals better performance. Also, there are automatic storage increases and automatically expand storage when nearing capacity. They also have high availability, which is recommended for production because it enables an automatic failover to another zone in the same region during outages, which supports cross-regional replicas for regional failure protection. It has automated backups with configurable times and locations that support instant recovery. It also has a migration workflow, which provides source details like public IP ports and replication credentials. And because it is a SQL database, the data is encrypted at rest and in transit, where external connections can use SSL and Cloud SQL proxies. Cloud SQL also works with apps running on App Engine, Cloud Run, Compute Engine, GKE, and Cloud Functions, as well as other external applications. It also talks about a pricing overview and use cases like payment systems and order processing. And the last video is this, which luckily I remember a lot of the SQL database training from the database class I've taken before, so this is a little redundant, so I'm not going to really go over this one. And that is it for this video lecture. Thank you, and I will see you next time.